Hello everyone, this is me, Muhammad Amir, and today we are going to learn the process lifecycle. In this video, we will learn how the processes creates and how the processes exits and the wait and how what is the process table in this video. Let's start. So the what is process lifecycle? The process lifecycles means in operating system, in Linux operating system, how the processes creates and how it manages inside the computer. So the process the in the computer or the operating system there is a process table. So what it does basically, it is a table that stores the PID, or we can say the process identifier, and the process, as you can see here. So with the help of identifier we can, or the system easily identified each process uniquely, because the PID is unique. So the PID we say in the full words as process identifier, in short PID. So it basically contains the unique integer value, and each unique integer value of each process, the with the help of this, the system easily identify each process with the help of unique ID, right? Now, so there is a first process that we call normally the parent process, and the process that we start when the computer starts. So the main process starts, right? Then with the help of from the parent, the child process creates. The child process creates with the help of fork function. So the for function, what it does, so it basically the for function creates another process of the same process, just like the parent one, right? So the child process can need resources it can directly get from the operating system, and it can inherit from the parent. The parent also have two types of resources, the shared resources and partition resources. In shared resources, many child processes can uh, access the same resources, right? And in partition, the resources are divided in only for a specific child or the child process, right? Now there is a running possibilities, like the process and the parent and the child can run concurrently, means parent and the child process can run uh, at the same time, right? And the parent, or the second possibility is parent can wait for the child process to complete. Now we are going to move forward. What is fork? So fork is a method or a function that duplicate the process. For example, there is a parent process is running, and inside the parent process we called the fork. So it basically creates another child process, just like same original. So what it copies the program plus data, right? So this I will explain you later when we will come to an example. For now, you remember that key fork basically duplicate the process. For example, there is a parent process that you are running, and any process that is running, so inside that process if there is a fork method or the function called, then that child process that creates with the help of fork, it also contains the same code that the parent process contains. Okay. Now exec, what it does, so it basically loads the child, child loads a new program. So basically it loads a new program into that process, whether it is a child process or a parent process. If it is loading any if it is loading any program, so it needs exec function. It basically takes two arguments. One argument takes file or the location of the file that it wants to load, or the program file, right? the arguments for the file that is going to load. For example, there is a XYZ program. We are loading with exec. So in the first argument, we will pass the location of that XYZ file or program, and then in the second arguments, we will pass the argument that required by that program, right? And the wait. Now move to the wait. Makes the parent process pause until the child. So what it does, makes the parent process pause until the child process finishes. So what it does basically, for example, you called or created another process or a child process inside the parent process. Then if you use wait function, then it will wait until that child process is not completed. After when it is completed, then it is then the parent process start executing from the next line of wherever the wait has written, right? So it basically prevents a zombie process. I will explain this also uh, in the next part of the video. And then it also collects child's exit status. So when we create another process, the child process, so it basically executes or calls the exit method or the function. Then this wait method collects or listen for that uh, exit message. Then or it basically collects the exit of the child's status. So whenever that child calls that exit function, that this wait function gets that or collected that exit status, and then it removes from the table, from the this process table, right? I will explain you everything about zombie process, and there is another one also. Then you will be understand easily. And now this is exit that we are talking about here. So what it does, it ends the process immediately. So wherever it calls this exit, so it exit that or end that process immediately wherever it calls. To release memory and resources, whatever the resources and the memory that process was containing, it releases all the resources and memory, and it sends the exit status to parent. So for example, this exit function calls inside the child component or the child process. Then what it does, the exit state, so it sends the exit status to the parent. From there the child process is created. Then parent collects its using wait. And if parent doesn't wait, if parent does not call the wait function, then the process becomes a zombie process. Okay, now I will explain these zombie process also, as I said before. Then we will take an example of this one also T. Then we will understand how the zombie process, and then that process runs, and how it executes in child and the process, and what is the meaning of it copies the same code as parent. Then it will it will why it is not running like loop, like recursion loop. So I will explain everything. Before explaining this example, I'm going to explain this zombie process and the orphan process. So a zombie process is a finished child process whose parent has not called wait yet. The zombie process is a process where a parent process created a child process, and whose and child process called which is calling exit, but the parent process is not calling wait. So it means if there is no wait, then the then the parent process will execute continuously. It will not stop, and the child process exited. But there is a entry of that child process inside the process table. But then if the parent process uh, calls wait, then it collects the exit status of the child. Then that wait method or the function responsible for removing the entry from the process table. But in this case, there is the parent process does not call uh, does not call the wait function. So it means it is not listening for the exit status for the child process. So the process has ended. The process is running for, and then process ended, but the entry of that process is still in the process table. So this is called the zombie process, means the process has completed and exited, but the entry of that process is still is in the process table. That is called zombie process. Now read more points of it. Process is dead, entry remains in process table. The ID still exists, as I said before you. Like here, if it is a child ID, and the whatever the function or the body of that process, it will remain. It will remain the entry. It will remain the entry of that child process in the process table, right? This is called zombie process. So it does not use a CPU, only table space whatever it requires. Then what is orphan process? An orphan process is a child process whose parent exited first, means process is alive, auto adapted by PID1, not harmful. Means the parent process created another child process, and that is running. But before before but parent is not called wait function also to complete that child process. And and the parent process is completed before the child process, right? If but then the child process is running and it is alive, then the what it does, the now modern kernel what does now, uh, the child process, there is no, that parent is already exited but the child is still running or alive, then it automatically adopted by PID1, means that child process becomes the parent process. So in orphan process, we can understand by the term of like where the parent process is exited first, exited first, but child process is still is running, and child process is still alive. So uh, in with this example you can understand what is orphan process. Now let's take understand this example. For example, this is our main process, right? This main process is running. So this is a parent process, and here we call another child process. What happened here? The child process will start executing from this line. This will not call this main method. It basically creates the child process and it will start executing from this line. Okay. Now this fork method, as I said you before, it will return any value. If it is a child, then it will return what? 0. Fork, what is return? Say 0. If it is a PID, if PID is 0, means it is a child process. If the id is greater than 0, it means it is a parent process. If it is negative, it means no process created, right? So here we created another child process, and so the parent one also and child both are executing. Now in this case, in this condition, the PID equal 0, the child process is created and child process child process returned 0. It means this will execute. Now we are calling exec function, and from this file the bin ls, and we are executing this ls command, and uh, executing ls command and exiting with 1 runs only if exec fails. So what happens here? The exec replaces that child process with the new program loads, so it will never returns back here. If it returns only in the condition of if this process fails, so it will remain here, and then if there is a parent child, if there is a parent process, then this condition will fail, and then it will come here else, and it will wait until that process is not executed, right? So it is waiting, then that exec method will call the exit, and this wait will listen for that exit, and then it will removes the entry from the process table that this fork method is created when it created. So the fork method entered a new entry of that new child process here, and after exiting, and this wait is listening for that, and after catching the exit status from the child, this wait removed that entry from the table. So what happens here? Now we see the fork the fork the what fork does, created a child ने क्या किया, execute the new program, and then child exit, then parent wait is removed the entry from the process table, and then process is also exit. Now how now take an example of what is zombie process, and what is orphan process with an diagram example, like. Now, what is happening here? Let's take an example for zombie process. In what happens in zombie process, the parent does not call wait. If we remove, this is a parent line. This is a parent line, and this one is child. Okay. Now, what is happening here? We created a child process, and then child is executing any another program, right? And it called exit. But for zombie process, let's take this one is not called. This exit is not. This wait is not called in parent process. So it directly goes to the exit one. Okay. So what happened, the process is completed, and there is no wait, the fork the parent process is running, and then exit has called. Okay, then exit has called after the child process has ended, so there is no wait called in the parent process. So in this case, the zombie process happens because the wait function is responsible for listening or collecting the status of the child process, and then it removes the entry from the process table. But there is no wait, then the entry will remain in the process table always. So it stores only the space of the table, whatever a particular process um, contains, whatever the particular process takes the space in the process table. Okay, but now there is a orphan process. So what happens here? In orphan process, we are not called यहाँ पे process we did not call, or the parent process did not call the process in the both cases, but this child is still running, but the parent process is exited first before the child finished. So now Now the child is still alive and the parent has exited. So the now modern kernel what does, they basically assigns the PID1 and makes that child process the parent process, and that process is called the orphan process.